Okay, so in the last lesson, when we talked about radicals, we simplified. All right, and remember, this is a review from last lesson. So you were asked to simplify, let's say, the square root of 8. Oops, sorry. I need to use a perfect square. So let's say the square root of 81 x to the 20th power. Okay, so remember what we did in the last class period. We asked ourselves, what squared will equal the radicand? So 81x to the 20th. All right, so that's what you're asked. So remember, when you're taking the square root of a radicand, your answer will be what you can square, what you can multiply by itself, so that you get the radicand back. Remember, that's a 20. All right, and so remember, the coefficient's easy. 9 times 9 is 81, so you know that a 9 has to go here. And then for x to the 20th, remember what we did, if you can't figure it out right away, you said, all right, this index is 2. Remember, there's no index there. It's understood to be a 2. That's why we call it square root, so that's a 2. And 20 divided by 2 is 10. So then what you want to do is say, well, that's going to be x to the 10th. And it kind of makes sense, because if I take 9x to the 10th and multiply it by itself, 9 times 9 is 81. X to the 10th times x to the 10th. Remember the product rule from last semester. When you multiply like bases, you add exponents. 10 plus 10 is 20. So this part right here is the answer. So you're going to say in the blank, you're going to say the answer is going to be 9x to the 10th. Okay? Now what we're going to do in this lesson, in part 2, is just extend it a little bit. So instead of having one variable here, let's add another variable. So let's do at least two variables. Okay, so again, you're going to be asked to simplify, and then for this part right here, let's assume that all the variables represent positive numbers. All right, now in the next section, in the next lesson, we're going to assume that's no longer the case, in which case we're going to talk about the absolute value. But in this case, let's assume they all represent positive numbers, and so we're not going to worry about absolute value. Positive numbers. Okay, so number 1, suppose I had the square root of, let's say, 25 x to the 8th power y to the 30th. All right, you're just extending it a little bit. It's the same idea here, except we're just adding one more variable. So just like this, you're going to ask yourself, what squared is going to be the radicand? Well, the radicand is 25 x to the 8th y to the 30th. But before I go on, make sure you understand why we said squared, because this is square root. If this was cube root, you'd say what cubed will be the radicand. Okay? All right, the 25 is easy, because we all know that 5 times 5 is 25, so 5 needs to go here. X to the 8th, y to the 30th, just think about what we did. My exponent's 8, my index is 2, so 8 divided by 2 is 4, so let's see if 4 works. So x to the 4th times x to the 4th is x to the 8th. When you multiply like bases, you add exponents. Now y to the 30th, 30 divided by 2 is 15, so we're going to say, let's see if that works, by y to the 15th. Y to the 15th times y to the 15th, because I'm squaring it, or multiplying it by itself. And so when I multiply like bases, I add exponents, and it's y to the 30th. So this is correct. So the answer here is going to be, on the blank, you're going to say 5 x to the 4th, y to the 15th. Okay, number 2, let's say we had the cube root of a negative, let's say 125, x to the 15th power, y to the 60th power. Let's say we had that. All right, so again, just like we did here, and the index is 3. Keep in mind the index is 3. So we're going to say what times itself 3 times what cubed is this radicand. So it's negative 125, x to the 15th, y to the 60th. Okay, so if you think about negative 125, try some numbers. You have access to calculator. 3 times 3 times 3 is not going to work because that's 27. 4 times 4 times 4 is not going to work because that's 64. 5 times 5 times 5, if you look at it, is 125, but I need a negative. So the only way I can multiply something by itself 3 times and get a negative 125 is if I have a negative 5. So a negative 5 times a negative 5 times a negative 5 is going to be negative 125. Negative 5 times negative 5 is 25, a positive 25, and a positive 25 times a negative 5 is a negative 125. Okay, now let's look at x to the 15th. So we're going to say 15 divided by 3 is 5, so I'm going to say x to the 5th. So let's see if it works. X to the 5th times x to the 5th times x to the 5th. Because remember, you're cubing, so you're multiplying this by itself 3 times. So when you multiply like bases, you add exponents. 5 plus 5 plus 5 is 15, so that works. And then let's do y to the 60th. 60 divided by 3 is 20. So that's y to the 20th power. So see if that works. Y to the 20th times y to the 20th times y to the 20th. When you multiply like bases, you add exponents. 20 plus 20 plus 20 is 60. All right. So the answer, the cube root of negative 125, x to the 15th, y to the 60th, is this right here. So it's negative 5, x to the 5th, y to the 20th. All right, number 3, suppose we had the square root of, let's say, 49 x to the 8th power divided by 64 y to the 16th power. Now, suppose we had this. All right, now, again, you could use this idea right here, the same idea we did here. So where you're asking yourself, what squared, this times to be a fraction. See, we didn't have a fraction here. This is a fraction. So you can say, what fraction squared will be this radicand? I need my radicand to be 49 x to the 8th divided by 64 y to the 16th. That's what you want. All right, let's start with the numerator. Just assume this denominator didn't exist right now. Let's look at the numerator. Well, we all know that's, remember, squaring, so what times itself? So we all know that 7 times 7 is 49, so we know that 7 goes here. All right, what about x to the 8th? Well, do the same thing you did with the others. 8 divided by 2 is 4, so I'm going to need x to the 4th. And always check yourself. And you could do it this way as well. 7 squared is 49. X to the 4th squared. When you have a power raised to power, remember the power rule. When you have a power raised to power, you multiply. 4 times 2 is 8. Or you could have just said, just like we did here, you could have said, well, x to the 4th times x to the 4th. When I multiply like bases, I add exponents, and it's x to the 8th. All right, now let's do the denominator. Assume the numerator didn't exist. So for 64, what times itself 2 times is 64? And the answer is 8, so I need an 8 down there. And I need y to the 16th, so something squared has to be y to the 16th. Well, 16 divided by 2 is 8, so see if y to the 8th works. So y to the 8th times y to the 8th, which is y to the 16th. And you could also say, I have y to the 8th, I'm squaring it, so when I have a power raised to power, 8 times 2 is 16. All right, so the answer is going to be this fraction right here. You put that in the blank. So the blanks will be 7 x to the 4th divided by 8 y to the 8th. Okay? All right, so that is part 2. Now, in the next lesson, we're going to talk about this idea, well, what happens when the variables are not necessarily positive numbers? What if they're negative numbers? So that's what we're going to talk about in the next lesson.